Hello, how are you? How are you doing? It's me, the pioneer in methods, the Professor Mourad Sultan Ezouidi is here to explain his theorem. Okay, so prepare your papers and everything that you can take with you and sit on your chair and concentrate on the lecture so that you can listen and start solving to the power. Okay, so from that, today my professor, my kids, and my colleagues, and my teachers, today we have the honor to explore groundbreaking advancements in the field of algebra, presented by the Professor Mourad Sultan Ezouidi, a mathematician whose deep research into polynomial equations has led to powerful new methods of solution. Contrary to the classical conclusion of the Bell theorem, which states that there is no general solution biological for polynomials of degree 5 or higher. So Professor Mourad Sultan Ezouidi introduced a novel theoretical framework that allows the exact solution of specific high-degree polynomial equations, including those of degree 11 and beyond, using what's now known as Ezouidi's theorem. We approach the following 11th degree polynomial equation. That's the polynomial equation. You can write it on your paper sheet. P of x equals x raised to the power 11 minus 33x raised to the power 10 plus 495 x raised to the power 9 minus 4,455 x raised to the power 8 plus 26,730 x raised to the power 7 minus 112,226 x raised to the power 6 plus 336,798 x raised to the power 5 minus 721,710 x raised to the power 4 plus 1,082,565 x cubed minus 1,082,565 x squared plus 7,649,539 minus 21,177,174 equals 0. This is the polynomial to the power 11, and we will demonstrate today and we will explain, or the Professor Mourad Sultan Ezouidi explains that this polynomial has elliptical roots. Okay, so unlike traditional methods that rely on approximation, numerical iteration, or claim impossibility, Ezouidi's method provides a systematic and exact decomposition of such equation. It's based on a combination of exact roots extraction, structural symmetry, and a new form of algebraic transformation that reveals the interval solvable layers of the polynomial. So here our lesson or the session, my professor and my kids and my colleagues and my learners is mastering the solution of 11th degree polynomial equation using Ezouidi method. It's not just about solving one equation, but in fact is about demonstrating that mathematics still has deep secrets, and that with vision and method, even the unsolvable can be solved with Mourad Sultan Ezouidi. Okay, we can say that we will make, let's say, a summary. We can say that in the world of algebra, certain varies have long been accepted as immutable, particularly the claim made by Niels Heinrich Abel in 1824. Abel's theorem tells that the polynomials of degree 5 or higher can't be solved biologically. That is, there is no general formula for their exact roots. Okay, but today the Professor Mourad Sultan Ezouidi explains that we can solve 11 degree polynomial equation or 12 degree polynomial equation, okay, and we'll get radical roots. Professor Ezouidi, or my work challenges, in fact, this very limitation, offering us a path to the exact solution of high-degree polynomial equations, including those as complex as degree level. So, in this session, my kids and my professors and teachers and colleagues will demonstrate the power of the Ezouidi theorem applied to the following 11-degree polynomial equation. So, as I told before, my polynomial equation is x raised to the power 11 minus 33 x raised to the power 10 plus 495 x raised to the power 9 plus 4,455 x raised to the power 8 plus 26,730 x raised to the power 7 minus 112,266 x raised to the power 6 plus 336,798 x raised to the power 5 minus 721,710 x raised to the power 4 plus my kids 1,565 x cubed minus 1,082,565 x squared plus 7,649,559 times x minus 21,177,173. So my kids here, let's start. First of all, I should share the screen with you. I'm going now to share the screen with you, my kids, and we are going to solve, let's say, nth degree polynomial equation where n is going to be equal 11, okay, and we'll show that we will get, let's say, the exact roots. Okay, so I think that now everything is clear for you. You can see everything. Okay, now my kids, this is our polynomial to the power 11. You can see x raised to the power 11 minus 33 x raised to the power 10 plus 495 x raised to the power 9 minus, okay, minus 4,455 x raised to the power 8 plus 26,730 x raised to the power 7 minus 112,266 x raised to the power 6 plus 336,798 x raised to the power 5 minus 72 million minus minus 721,710 x raised to the power 4 plus 1,082,565 x cubed minus 1,082,565 x squared plus 7,649,539 x minus 21,177,174 equals 0. So here, this is our 11-degree polynomial equation. We'll apply Ezouidi theorem, and we'll find, let's say, the new 11-degree polynomial equation that depends on its coefficient. Okay, well, that will be derived from Ezouidi theorem or the discriminant formula of Professor Mourad Sultan Ezouidi, and then you will see that this 11-degree polynomial equation, in fact, we can solve it using a radical. Okay, means this example is a contrary example of Abel's theorem. Okay, because Abel's theorem tells that the degree more than 4 or 5, we can find general formula to solve and to get a radical solution with a radical. Okay, so here we will learn, professors and teachers and colleagues and learners, how can you apply Ezouidi theorem and how can this method help you to solve any degree from the equation whatsoever the degree of the polynomial I worked with. Okay, so let's focus on this polynomial to the power 11 in order to find, let's say, okay, in order to find, let's say, the roots of this polynomial to the power 11, first of all, you should determine, my professors and teachers and colleagues and students, the value of xr for the q, where r ranges from 0 to 10, because the highest power is 11, so 11 minus 1 is going to be 10, and we're going to start from 0. Okay, now you can, if you want to equate this polynomial to the power 11 to its standard form, you will see that L042 is 33, and L1 is 495, and L2 is 4,455, and so on, up we will get L10 equal 72 million, L10 equals 21,177,000 and what else? And 174. Okay, so we'll start. We'll start, my kids. Okay, so here I'm going to apply, to use Ezouidi theorem, means I'm going to find s minus 1 and s0 and s1 and s2 and s3 up to s10. Okay, so here by calculation you can use your own calculators, my kids. Okay, and you will see the s minus 1 by convention, or using Ezouidi theorem is going to be equal always 1. Okay, meaning s minus 1 is 1. Also here l minus 1 of order 2 is 1. Okay, the first coefficient of the term x to the power 11 is going to be 1. Okay, now we are going to continue. I'm going to find the s0. S0 in fact is the sum of the absolutes of this new 11-degree triangle equation that corresponds to the original 11-degree triangle equation. Okay, so let's start. Okay, so we can see that this is S0. S0 in fact is going to be equal to 0. Okay, using the formula, we will be derived to the last one, which is n minus n times L0 plus 2. So we just make substitution and get that is going to be equal to 0. We move to the next value of the second coefficient of my new 11-degree equation. I want to find S1, my fix. To find S1, just set k equal to in the distant formula of Mourad Sultan Ezouidi, and everything will be clear. Okay, so okay, now we can say that S1 of 42, my kids, is going to be equal to negative combination of 2 and 0 squared plus n squared times n1 equal to 2. This one, when n equal 2, we will get quadratic formula, quadratic equation. Okay, so this is the distant formula. But this one, in fact, is not the distant formula we used to use before. Okay, this one is called the coefficient, the second coefficient of new second degree polynomial equation. If you are going to solve second degree polynomial equation and so on. So here we continue. We call that S1. In fact, you make your substitution. Exchange, let's say L0 with 33 and L1 with 495. You get the value of S1 is going to be equal to 0. We proceed. We continue. You are now Mr. Professor Mourad Sultan Ezouidi explains how you can find the coefficients of your new 11-degree polynomial equation. Okay, that has a relationship between the original 11-degree polynomial equation. So Professor Mourad Sultan Ezouidi explains that S2, to get S2, just go to his formula, his theorem, and put k equal to 3. This is the formula, the theorem of Mr. Mourad Sultan Ezouidi. Go and write k equal 3. You will get 3 minus 1 will give you S2. Then make the expansion and write it in its simplest form. Okay, like that, and make it like that. Okay, so this one, my kids, is this one is what is the third coefficient of my 11-degree polynomial equation. So after finding and writing your formula in its lowest term and making L042 raised to the power 3 as a common factor, and make the difference between n cn minus 1, or choose 2, from n choose 3, you will get that this one is going to be equal combination, what is it? Combination 2 choose 1 times combination n choose 3, and the rest will change according to the formula. Okay, make your own substitution and change, let's say, okay, green, it's better. Okay. Okay. Now we continue, my kids. We continue. Now S2, when you make substitution, you get that the value of S2 is going to be equal to 0. Okay, we continue. I want to find what? I want to find exactly the value of S3. To find S3, it's very easy. Go and make, we are still waiting. Okay. Okay. Good. So now we thought the S2 is going to be equal to 0. I want to find S3. S3 will give you the fourth coefficient of the 11th degree from the equation, which is new, that has relationship between relationship to the original 11th degree from the equation. We'll proceed the strategy or the procedure, and we'll see that S3 in fact also is going to be equal to 0. This is S2 just substitution. This is S2 my kids. Substitute it, substitute L0 with 33, L1 with 495, and L2 with 4455. You get the value of this is going to be equal to 0. Use your own self calculator, okay, and write your notes down, okay. And now we are going to focus on the fourth coefficient of my 11 degree from the equation. Here, the Professor Mourad Sultan Ezouidi explained that when k equals 4 in his theorem, we will get S3 equal this equal negative combination to 3 times combination n to 4 at 0 for 4 plus combination n minus 6 to 2 n squared times n squared times n1 minus n minus 8 to 1 times n cubic times 0.2 times n2 plus n raised to 4 times n3. So Mr. Mourad Sultan Ezouidi, or the Professor Mourad Sultan Ezouidi, explained that S3 is written as that. Okay, there is no other formula as this one. Okay, this one will give you exact the coefficient of the fourth. Will give you the fourth coefficient of your nth degree from the equation. Here in our example, n is going to be 11. Okay. Now we continue. We make just substitution. Okay. L0 with 33, L1 with 495, L2 with 4455, and L3 with this. Means in this formula for S3, we just need the fourth coefficient. L0, L1, L2, L3. Okay? Because the last coefficient is L3. So make your own calculation and you get that it's going to be, in fact, a no. Okay? So now we proceed. We told that S3 equals 0. To find now S4, you should, let's say, put K equal 4 in Ezouidi theorem. And here, the Professor Mourad Sultan Ezouidi explained that S4 is going to be equal to that. This formula is generalized for any n degree polynomial equation. This S4 means will give you the fifth coefficient of your n degree polynomial equation. No discussion. Close the prayer, please. Okay? So, and which coefficient you are going to use from the original 11 degree polynomial equation are the following: L0, L1, L2, L3, and L4. Okay, and n is going to be equal to 11. Just change the replacement or substitution and make S4 as that numerical value, and you will get that is in fact equal to 0. Okay, now we can summarize it. We found S0 equals 0, S1 equals 0, S2, S3, and S4. We continue. We'll find also S5 and S6 and S7, S8 and S9, and we stop at S10, the 11th coefficient of my 11th degree from the equation. So here, put k equal 6 in the discriminant formula or in the Ezouidi theorem, okay? So, and you are going to write your formula in its simplest form, which is written as S subscript 5 of order R, which is equal to this, okay? So now, what you need exactly, my professors and my learners and my colleagues and my teachers, is just make your own substitution and choose your and use your calculators and figure out that the value of S5 is equal to an L. Okay, we continue. We continue, my kids. So we told that this one is going to be 0, just substitution. This one, I mean. So just substitution and do your best and make your own calculation and tell that in fact it's going to be an L. Okay, we continue. To find now S6, my learners, you should put k equal 7 in the theorem of Professor Mourad Sultan Ezouidi, which is written as S subscript k minus 1 of order R the sum from 0 to k, combination n minus r to k minus r, and raised to the power r between parentheses individual 0 to the q raised to the power k minus r times lr minus 1 of 2. Okay, this sum, we expanded it and we divided it, and we see that a 0 of order 7 is a common factor. We put it here. And we make the difference between n cn minus 1 to 6 and cn to 7. We got that is in fact equal combination 6 to 1 times combination n to 7. Okay? And here n is going to be 11. We just change the value of n minus 2 by 11 minus 2, which is 9, n minus 3, 11 minus 3, which is 8, and so on. Okay? Till we reach the last one, which is 0 as combination n minus 5 to 0, which is 1, so no need to write it here. That's why he is more written 1, so no need. Okay, now you got this expression. This expression at 7 will give you the seventh coefficient of what? Of your integral equation. Whatsoever the highest, the power of the following that you are to need. So this is S6. S6 is like that. Okay. So here, my kids, you are going to continue and make your own substitution. You have, let's say, the coefficient of your original 11-degree column equation. Just put in this formula, the last one, I mean. The last one I will try to make like that. Okay. Okay. This one, I mean. So now, if you are going to use, let's say, to substitute L0 and L1 and L2, L3, L4, and L5 up to L6, because the last one is L6. So you will find that it's part is equal to to 0. Okay, we continue. This is, let's say, an example for you to train yourself and to see that, in fact, this is a contrary example for double theorem, because double theorem from that from 5 and higher, we cannot find general solution. So this method, maybe the Bell before in 1824, he didn't have this formula of the Professor Mourad Sultan Ezouidi. Okay, so we continue. He did his best, but Mr. Mourad Sultan Ezouidi involved his tools and his uh, techniques, and let's say discovered something really unbelievable, and make things which are insoluble to be solved with something needs, let's say, power of thinking and power of determination to dive into this nth-degree form equation, and to dive also into the nth-degree linear equation, okay, and the relationship between nth linear equation and nth-degree form equation. Many things, in fact, and also about the sum of powers of the roots. Very, very, very important. This field of algebra. In algebra, we continue. We thought that we need now to find a 7, my kids. Just put k equal equal 8, or use Mourad Sultan Ezouidi theorem by making k equal 8. We obtain 8 minus 1 as 7, and then k here is 8, 8 minus r, and so on. After making your own expansion and simplifying this by seeing or noticing that a 0 to the power 8 is a common factor, you can put it here as a common factor and make the difference between this and that, and you will get that this one is going to be negative combination 7 to 1 times combination n to 8, and then changing n with 11, and the rest will be the same by putting n equal 11 and let's say keeping the coefficient of your original irregularity from the equation. So here, my kids, we make our substitution and we calculated this. Means that this is the formula. You see this formula is the same as that, but we put, instead of writing L0, we put 33. Instead of writing L1, we put here 495. Means that we change the coefficient of our original differential equation in the ZB theorem. And we find the coefficient of the new differential equation is the eighth coefficient. The eighth coefficient here, my kids, the to be clear, is going to be equal to an L. Okay, let's continue. We continue now to find S8. We should, let's say, put K equal 9. And here, Professor Mourad Sultan Ezouidi explains when putting K equal 9 in his formula, you will obtain S8. S8 will give you the 9th coefficient of your n degree from equation, because this one is going to be n, meaning that you are working with n degree. But here in our example is 11. So I'm going to change that after that in n with 11. Okay. So it's an occasion for you, and you are welcome, professors, okay, from the whole world, okay, from any universities in the world, to apply and to use the theorem, because it's very important, and it will help you also to solve nth linear equation, okay. And the nth linear equation, in fact, it's another thing which is very hard, okay, but we reach to solve a linear equation, okay, not like from the equation. But okay, by the way, we continue. This is not our topic. Now we focus on the value of S8. My kids here, this is the general formula for any n degree from the equation. This S8 will give you the ninth coefficient of your n degree from the equation. Okay, so you need now just calculation and substitution. Make your own substitution, and you will find that this one is equal to an O. Okay, make your own substitution. You will use just L0 up to L8. Okay, because this is S8. Okay, so this S8 is going to be equal to 0. Okay, we summarize between parentheses as S minus 1 different to 0. S1, S2, S3, S4, S5, S6, S7, S8 are equal to 0. Let's check S9. Okay, S9, Mr. Mourad. So Professor Mourad Sultan Ezouidi explained that S9 is going to be different to 0, not equal to 0. Okay, and S10 is going to be equal to 0. Okay, let's see, Mr. Mourad. So this is for K equal 10, we write, okay, and we'll use Ezouidi Mourad theorem, this one, and we'll obtain that S9 is equal to combination n choose 10 times L0 for the q raised to the power 10 minus n, combination n minus 1 choose 9, L0 for the q raised to the power 9 times L0 for the q. You can see this one, L0, 9, and L0 to the power 1 is a common factor, because this and that are equal. So put as a common factor and make the difference between this and that. After that, put the things as they are here, okay? Because the rest, they are written in X in their lowest term, no need. But just the first two coefficients, just make the difference between them, and you will write, and you will focus on the last formula, which is this one, S9, is that. S9 is equal to negative n choose 9 choose 1 times combination n choose 10. Okay, times L0 for the q raised to the power 10 plus combination n minus 2 choose 8. N squared L0 for the q raised to the power 8 times 1 minus combination n minus 3 choose 7. N raised to the power 3 L0 for the q raised to the power 7 times L2 plus combination n minus 4 choose 6 times n raised to the power 4 times L0 for the q raised to the power 6 times L3 minus combination n minus 5 choose 5, n raised to the power 5 times L0 for the q raised to the power 5 times L4 for the q plus combination n minus 6 choose 4, n raised to the power 6 times L0 for the q raised to the power 4 times L5 for the q minus combination n minus 7 choose 3 times n raised to the power 7 times L0 for the q raised to the power 3 times L0 L6 for the q plus combination n minus 8 choose 2 times n raised to the power 8 times L0 for the q squared times L7 for the q minus combination n minus 9 choose 1 times n raised to the power 9 times L0 for the q raised to the power 1 times L0 for the q, L8 for the q plus n raised to the power 10 times L9 for the q. Here I will give, let's say, a slight idea about solving or mastering the solution of n degree linear equation. Linear equation has to be written as that, xn, not x raised to the power n. Now, x subscript n minus 0 over the q, x subscript n minus 1, plus L1 for the q, x subscript n minus 2, up to Ln minus 2, of order q x subscript 1. This is the nth degree linear equation. Okay, so you will, in order to solve this nth linear degree equation, you should, let's say, construct the nth Laplace linear equation. Means you are going to work, for example, to work with L0 of order nq, L0 of order n minus 1q. What does it mean L0 of order nq or q n? Means that the sum of powers to the power n to the power q raised to the power n. It will be written as alpha 1 to the power nq. Q is not cancelled, means it's vary, let's say vary between 1, 2, 3, and so on. This depends on the highest power very often. And after making this, you will get a matrix, okay, square matrix, n by n, okay, and you will solve each one, and you will get your roots of your linear equation. It's not easy this topic, but we hope so that one day I will start doing it. But now I'm focused on solving n degree from equation till till we found, let's say, we will find, let's say, space or uh, let's say time to start it. Okay. By the way, this is S9 will give you the 10th we say, the 10th coefficient of your n degree from the equation. So by calculation, my kids, you see, we calculate all of this, okay, and we found that it's 7, 10 raised to the power 6 times 11 raised to the power 11. Oh my God, yeah, okay. So if you want to do it, I will just do this for you. Calculator, Mr. Mourad. Okay, comes up here. Again here. Okay. So this one, my kids. Oh, stop. No, stop. Okay, like this. Yeah. So this one, my kids, in fact, is equal the sum all of this. No, where is S8? Not S8. S9. Okay. S9. We reach S9, isn't it? So we stop here. Okay. So this one, my kids, in fact, is equal to all of this. I will stop at this. Okay, only at this. Okay, from this to that. The last I will keep. I will explain after. Okay, so this one is equal to negative 6,049,539 multiplied by 11 multiplied by 11 raised to the power 10. Why is raised? Raised to the power 10. Then plus what? Plus 11 raised to the power 10 multiply by 7,000 7,006,049, I think. Okay, yes, 539. This one, my kids, is equal to again, okay, that's it. Negative 6,000 and negative 6,000 and 649,000 multiply 539 multiply by 11 raised to the power 10 plus 7,000,000 and 6,049 539 multiplied by 11 raised to the power 10. So this one is in fact is equal. Let's call it this one. Okay. So you see here, scientific calculation and make mistake. Okay. Okay, look here. I will ignore this one, 11 raised to the power 10 and 11 raised to the power 10. Okay? Okay. Look. Okay. It will be negative 6,000, 400 and 649,000. Okay. 649,539. Okay, equal. I will make equal. Equal. Plus 7,649,539. Isn't like that. This is equal 7,000. Multiply by 11 raised to the power 10. Okay. So it will be 7,000, 7 million times 11 raised to the power 10. Okay. Divided by 11 raised to the power 10. Okay. Okay, this is 7,000. That's why he wrote it as 7 times 7 million. 7 times 10 raised to the power 6 times 11 raised to the power 10. Okay. If you want to ignore this step and make your own calculation, you can see that, my kids, 33 is 3 times 11. And this one, you may just make 11 raised to the power 10. Put as a common factor. This is 11 raised to the power 2 times 11 raised to the power 8 is 11 raised to the power 10. Just put 3 raised to the power 8. Okay? So I will keep 11 raised to the power 10 as a common factor. I will never calculate it. Then I'm going to calculate the rest coefficient. So it will be negative 99 because negative 99 because 9 by 11. Multiply by 3. Multiply by 3 raised to the power 10. Okay. Then plus 9 times plus 9 multiply by what? 9 multiply by 3 raised to the power 8. Because 11 raised to the power 8 times 11 raised to the power 2 is 11 raised to the power 10. Is a common factor I will put outside. So I'll just make combination 9 choose 8 times 3 raised to the power 8 times 495. Okay, times 3 times 3 raised to the power 8. Okay. Then multiply by 400, multiply by 495. We move to the next. Minus 8 multiplied by 3 raised to the power 7 times 445. Minus 8 multiplied by 3 raised to the power 7. This is 7 to the power 7. Then multiply by 4,400 and multiply by, I'll put this here so you can see it. Okay, multiply by, no problem. Raised to the power 7 multiply by 455. Okay, I'll put this one, the calculator, I'll put here so you can see it, my kids. Yes, a moment. Okay, you can see it now, isn't it? In front of you. Okay. Okay. So, then plus 7 multiply by 3 raised to the power 6, by 3 raised to the power 6, 3 raised to the power 6. Then multiply by what? Multiply by 26,000. Multiply by 26,730. Okay. Then minus 6. Multiply by 3 raised to the power 5. 3 raised to the power 5. Multiply by 112,266. Okay, like that. 1, 2, 3, 6, 6. Then plus 5 times 3 raised to the power 4. Plus 5 times 3 raised to the power 4 is 81, isn't it? I will write 81. Multiply by 336,798. 798. Okay. Minus 4 multiplied by 3 cubed means 27. Minus 4 multiplied by 27. 3 cubed by 27. Multiply by what? By 725. Multiply by 721,710. This one. Plus 3 times 3 squared. Plus 3 times 9. 3 squared is 9. Is 9. Okay. Times 1 million. Times 1 million. 82,565. Then minus 2 times 3 only. You see, this is 33. You can write as 11 times 3. 11 times 11 raised to the power 9 is 11 raised to the power 10. That's why I told you 11 raised to the power 10 is a factor. So, we told negative, what is it? Yes, we finished this one, isn't it? Now negative 2 times 3. Negative 2 times 3 means 6. Negative 6. Times 1 million times 1 million and 82,565 plus 7,649,539. I will make plus here. Plus what? Plus 7,649,539. So this one is equal to 7 million, and you should multiply by 11 raised to the power 10. That's why we wrote it as 7 times 10 raised to the power 6 times 11 raised to the power 10. Okay? So now as mine is different to do. Okay. We continue, my kids. Now in order to find the 11th coefficient of your 11th degree from the equation that corresponds to the original 11th degree from the equation, we should put k equal 11 in Ezouidi theorem. And here, Professor Mourad Sultan Ezouidi explained that S10, the 11th coefficient, is given by the value of S10, by this formula. This formula S10, this one, is the general formula for any degree formula equation. This S10 will give you, for example, if you are working with 16 degree or 20 degree or 100 degree or 101st degree formula equation, S10 will give you the 11th coefficient of your n degree formula equation. Okay? So, this is the formula, has been written in its lowest term, okay, that derived from the Ezouidi formula, and now just put substitution. You will change in this formula all the coefficients. L0 with 33, L1 with 495, up to L10 with 21,177,147. Okay, so I will make substitution here, and I will obtain that S10 is equal to 0. What does mean S10 equal to 0? The last coefficient equal to 0 means what? Means that your 11th or your original 11th degree from equation has a root of order of multiplicity equal 1. Okay, it's clear here. Well, that's why S10 equals 0. S10 equals 0 means that your polynomial to the power 11 has a root with an order of multiplicity with 1, which is equal order of multiplicity. If S10 and S9 equal 0 means, for example, alpha equal 2 or 3 whatsoever, has a double, it's a double root, meaning that the order of multiplicity is going to be 2. Meaning you can factorize it as x minus alpha raised to the power 2, for example, okay? But the method of Mourad Sultan Ezouidi never look for factorization or using classic method or, okay? There is theorem, apply the theorem and do your best. Okay. So here we make summarize, my kids. In other words, S0 equals 0, S1 equals 0, S2 equals 0, S3 equals 0, S4 equals 0, S5 equals 0, S6 equals 0, S7 equals 0, S8 equals 0, S9 equals 7 million times 11 raised to the power 10. S10 equals 0. The last term is 10 equals 0 means that we will get a root immediately. Immediately you divide this by 11, the second term of your original 11 degree equation. Mean 33 divided by 11, it will be 3. 3 is a real root with one of order multiplicity, and it's clear. Okay, so now I will write my new 11 degree polynomial equation in terms of its coefficient s subscript k minus 1. It will be written as that: x raised to the power 11 minus s0 for the r, x raised to the power 10, plus s1 for the r, x raised to the power 9, minus s2 for the r, x raised to the power 8, plus s3 for the r, x raised to the power 7, minus s4 for the r, x raised to the power 6, plus s5 for the r, x raised to the power 5, minus s6 for the r, x raised to the power 4, plus s7 for the r, x raised to the power 3. Always the subscript, the index plus the power will give you 11. S8, okay, 7, yes, this will give you 10. Yes. So, okay, okay, yes, because minus 1 plus 11, 10. So, S6 for the R, x to the power 4, plus S7 for the R raised to x cubed, okay, minus S8 for the R, x to the power 3, plus S9 for the R, x to the power 1, minus S10. So, S10 is equal to 0. This is equal to 0, x 0, 0, 0. I will just keep the last one plus S9 for the x. So, this one, it will be like that. This will be plus Mr. Mourad, this is possible. It is more. This is plus, yes. So, because plus S9, this is plus S9, times x equals 0, means I will put x into my factor because it's clear that it's 0. So x equals 0, or x raised to the power 10 plus 7 million times 11 raised to the power 10 equals 0. So x equals 0, it's clear. Now I'm going to focus on this one. So this one equals 0 means x raised to the power 10 equal negative 7 million times 10 raised to the power 10. So there is a negative sign here. You can put here exponential 2k I5 because always equal to 1. But I appeared here. Okay, so Professor Mourad Sultan Ezouidi explains that x equals 0 or x subscript k ranges from 0 to 9 is equal to 7 million times 11 raised to the power 10 all raised to the power 1 divided by 10 times exponential 2k plus 1 I pi over 10. Why 2k plus 1? Because there is a negative sign here in this. Okay? It will be exponential I pi, which is equal to minus 1, and then divide by 10. Okay, so x equals 0 or x subscript k from 0 to 9 is equal to 11. Why? 11 raised to the power 10, all raised to the power 1 over 10. So the powers and indices, they will be cancelled out. It will be 1 times 10. 10 divided by 10 is 1. That's why here we put 11 only to the power 1. It's 11. But the rest will be in terms of root, okay? So it will be 7 million raised to the power 1 over 10 times exponential to k plus 1 I pi over 10. So this one, these are the x roots of your new 11 degree polynomial equation that derived from the coefficient, let's say from the theorem, Ezouidi theorem, or this formula of Ezouidi. Okay. Now, my kids, it's easy, my professors. So the roots, the roots of your original 11 degree equations that we started with, alpha subscript k 0 to 9 is a0 for dq, the first and the second coefficient of your original 11 degree equation, which is 33 in fact, plus the x roots of your new 11 degree equation divided by n is 11 because the highest power is 11. So it will be 33 plus 11 times 7 million raised to the power 1 over 10 times 2k I pi, 2k plus 1 I pi divided by 10. So 33 divided by 11 is 2. 11 divided by 11 is 1. So these are the roots of your original 11 degree equation. Okay, there is here two roots in fact. When k equal let's say two real roots. So the real root is this one. When x equals 0, x11, x11 is going to be 0, 33 plus plus 0, the 11th will be factory of 11th will be 3. This is, it's clear, the is everything. That's the rest are complex roots, but I'm going to check if it is 0, okay, complex, 5, it will be, yes, yes, all of this we have 10 complex roots, 10 complex roots, and one element. Okay, this is according to Mr. Watson Ezouidi, and we prove that with radical we can solve 11 degree from equation with radical, and this is a contrary example for uh, to Abel's theorem. Okay, thank you for listening, and see you next time. Assalamu alaikum. I will make save first. Save, save, that channel. So I wish that you got the point. How can you solve the 11 degree from equation using the Ezouidi theorem? And in this chapter, or this session, Professor Mourad Sultan Ezouidi explained how can you use his theorem and how the theorem will give you exact proofs. Okay, it's not easy this work. Okay, but we hope so that you'll apply the formula and you will get rid of classical method like Newton method or Abel section, okay, and so on. Okay, so thank you for listening, and this is Mr. Martin Ezouidi with you always. Okay, and we hope so that you got the point. How can you solve this 20 to the power 11? Okay, thank you for listening. See you inshallah next time. So as we told, just to summarize, so we can say that in the world of algebra, certain values have long been accepted in method, particularly in the claim made by Niels Hernek Abel in 1822. Abel's theorem tells that or tells us that polynomials of degree 5 or higher can't be solved by radical. That is, that's it. There is no general formula of their exact solution. Okay, so here, my kids, in this example, okay, we can say that we solve with 11 degree from equation, which is beyond 5, okay, uh, beyond of degree 5 or higher, and we can really break it down and give your exact roots. And thank you for listening. Thank you and goodbye.